Okay. This is where we left off Tuesday night. We had a remainder of 26, and I showed you two different ways that you can demonstrate that remainder. Okay. You could show it in as negative 26 over x minus 2, the fractional form, or just simply remainder 26. Now, how did you check long division in grade school? Well, let's go back to my old example of 5 into 17 goes 3 times 15 with 2 remainder. If we were asked to check this, then we would take this times that and add the remainder to check it. And it better all add up to 17. If you take this and multiply it times that by foiling or distribution, and then you add a negative 26 to whatever you get for these two multiplied together, you better get that. Okay, same way we did over there. Now let's go on. Here's just kind of a summary of this thing. The quotient, okay, the answer, quotient is the answer to a division problem. Remember from your clue word sheet. The remainder, in this case, negative 26, the divisor, x minus 2, and the dividend is this. Okay. Here, they're saying you take the quotient plus the remainder over the divisor. That was just that fractional form that I gave you earlier last night.
Yeah, I thought that Alex prefers the quotient plus remainder over the divisor.
Pretty universally. And in college algebra, absolutely. So just get in the habit of that being the default way of showing if there is a remainder. Okay. Here, this just tells you what I said up here. You take the divisor times the quotient and add the remainder, you get what's under the box. Okay. Here, the divisor times this, multiply those two together by distribution, add negative 26, and it does in fact check. So this is just kind of a summarization of what we did the other night on this problem. It's checking, so to speak. Now, do I expect you to do this check on every problem? Look, I'm not stupid. You might do it once in a while, but I know you're not going to do it all the time. So, you know, why pretend? Okay, so let's work this one. Looks like I get to work this one. 4x squared plus 6x minus 8. I think I'm not in the hot spot there. And I'm going to divide that by x plus 3. Well, the first thing I need to check, now I'm adding something to do in here. Look at your powers, 2, 1, 0. Okay? So we're okay. In a little bit, you're going to have some problems where you've got a missing power. And I'm going to show you how to compensate for that, but not yet. Okay? So here's my estimator. We're going to go through our 4 steps. Estimate, multiply, subtract, bring down, over and over again. Where's my first digit of my answer? Well, I got 2 here, I got 2 there, so right there it's going to be. Now, what do I have to do to this x to get that? Well, I have to multiply it times 4x. So 4x. 4x times x is 4x squared plus 4x times 3 is 12x. Now I have to subtract. How do I subtract? Change both signs and add. Well, these two are opposites, so they wipe out. Over here, I'm going to get negative 6x. And I bring down. Now I go through my estimation cycle again. What do I do to x to get negative 6x? Minus 6. Okay. Negative 6 times x is negative 6x. Negative 6 times 3 is negative 18. I subtract by changing both signs and adding. These two are opposites, they wipe out. And these two give me positive 10. Okay, so in this case, my answer is 4x minus 6 plus 10 over x plus 3.
Why did you put 4x and 6x and not? Because it doesn't have a square.
Okay. Goes back to long division with numbers. Remember I had 27 the other day, and over here I had 1, 2, 3, 4, and so on. 27 won't go into 12. It will go into here. So that's how we did that here. But in this case, we've got 2 terms that are sequentially power-wise. So I have to have this 2 terms go into 2 terms. Now, you're going to see and may have seen in high school, I don't think Alex does this, but sometimes you're going to see him go ahead and put this 4x here and the minus 6 there and whatever. Look at my x's. They align when you do it this way that I'm telling you. Okay? My numbers align. What if I had an x to the 5th up here for my first term? By doing it the way I've shown you here, every power will align. Okay? Again, that's one of those prevention of error things. Any questions about this problem? Was that just propping your elbow up or okay? Okay, now I've got something besides a 1 right there. Here they write it out. Uh-oh, look at this. I gave you a prediction of this a moment ago. 3, 2, 0. I'm missing my first power of x. So I have to put it in here. Because technically this is x to the 1st. Okay, so you have to have every power represented before you can divide. Not only is that true in long division that we're doing now, but it also will be true in synthetic division, which we'll do a little later tonight. Okay, if you've got any missing degrees, You've got to put them in with 0 of them. Okay. Now, I suppose the best illustration I could give as to why we have to do this is this. Okay, that's in words, right? How do we have to write this in numbers? So we have to put in that placeholder 0 when we convert language to numbers. Just like we have to put that hidden 0, that placeholder 0 in here before we can divide. Light bulb came on, didn't it? Okay. I guess tonight was a success there. Okay, here we go. Same thing we did before. Here is my estimator. What do I have to do to this 2x to get negative 3x cubed or negative 2x cubed? Well, I have to multiply it by negative x squared. No, 2. So I have to multiply it by negative x squared. Okay. What did I do? Go backwards. They're just telling, this is just showing you why it's negative x squared. So there we put the negative x squared. I take negative x squared times 2x and I get this. I take negative x squared times this. And again, I like to go ahead and put parentheses around here so you don't forget that you got to distribute to both of these. Okay. So here's what we get when we multiply those out. Now they're showing it this way. And oh, what's a negative times a negative? What's a negative times a positive? That's why I say just go through and change both signs. Okay? Because it has the same effect. And it also keeps you from doing it to this one and forgetting that one. So we're going to get rid of that. Okay, here they've actually done that. Okay. So these are opposites. Here I get negative 14x squared. And I bring down. I'm not bringing down nothing, I'm bringing down a placeholder. Okay, I do my estimation again. What do I have to do to 2x to get this? Negative 7x. There's the y. So here we put in. So I distribute. And I get that. There's a plus in front of this. Okay. And so these two will wipe out like they're supposed to. This gives me negative 28x. And I bring down. What do I have to do to this time? Negative 14. Okay, so negative 14 times this, negative 14 times that. I change both of these signs. And that's opposites, they wipe out. Those are opposites too. Okay, what's bothering you? Okay. Here,
Yes.
I have this, and I have that.
Okay, I missed the.
And then-
the orders.
I changed both signs. Okay? Oh, that would be a plus there.
It's already just.
Okay, so now I've got opposites, opposites, remainder of 0. So in this case, we've got this and we got that. What have we done to this thing? We have reduced that equation by 1 degree to that. Basically, we have taken this equation and we have factored out that, getting this. We could list this answer in factored form if it asked you, 2x minus 4 times negative x squared minus 7x minus 14. And then if we wanted to, we could try to factor this thing. And if we could factor it, and I don't know whether it will or not, it probably will after you factor out a -1. Then you would have this broken down into its base factors for all 3 degrees, all 3 powers. And you could graph it. Guess what? Previews of coming distractions. They will give you an equation like this, and you got to try out stuff. And there are some ways to go about knowing what to try out to see if you can bring this down at least 1 degree. Now, when we get something to the 2nd degree, we can also use the quadratic formula instead of factoring. Okay.
So what would you write as the answer? Just like what we got.
The answer on this one is just this distance, because we had no remainder. Okay, here's 3 more problems I'm going to let you look at. You may or may not want to copy them down. Well, okay. There's a method called synthetic division. That's it shown here and here and here that I haven't taught you yet. And I was just showing you a comparison of the 2 ways. And here you got the 2 out there, and here you got the 2 out front. Now, let's go to this one. Okay, what are we going to do on this one? What have I got missing?
The y squared.
The y squared is missing, isn't it? So what you're going to have to do on this one then is change this to 4y cubed minus 0y squared plus or minus, I mean, doesn't matter. Minus 2y plus 2. And then we're going to divide it by 2y plus 2. You do that. You do this. I'll give you a hint. There's the first digit of your answer. And while you guys are working it, I'm gonna be working it silently up here. Hey, anyone have a question? Okay, obviously, a couple of you got stuck at some point in this problem. Where did you get stuck? Which step?
Is negative 2y plus 4y not equal to 2?
Where?
Right, like, just at the end of where you want it.
Here.
Yeah. So when you,
-2 and +4 makes +2 of it.
but with those y stuff.
They would still be y's. You're not dividing, you're subtracting. So the y stays there. Okay, good question. Any others?
I just forgot to do some sense on it.
Oh,
Yeah, that was the same with me.
Well, that's why I do it the way I do it, is just simply, after you multiply, then you simply change both sides every time. Okay? And then add.
So if you ever came into a thing that the signs were already correct, would you still change them?
Yeah. You would have to change them no matter what, because that's the subtraction step. Any more questions on this? Okay. I suppose I probably should start repeating questions for the sake of that thing. Okay, here's another one. This one's kind of a bad nasty. Look at this. Not only is there, well, these powers aren't even in the right order. The biggest one is fourth, then a third, and they're missing the second degree. So you got to put in a placeholder, and then that, and then this. And then you go up here in the front, and you're missing the first degree. So you got to put it in there too. Okay. I used to have one like this on my test, but I changed it around where you don't have to do it on the outside, but technically you need to know that. Well, let's go ahead and work this one. Okay, They got their, notice 1, 2, 3 terms, 1, 2, 3 terms for the answer. Okay, we got that. When we multiplied, now they're gonna subtract everything and in the process change the sign of, well, they didn't show it. Bad on them. Let's change this one to negative. Let's change this one to negative. And let's change this one to positive. Okay, those two wipe out. This gives me positive 15. That gives me positive 12x squared. Estimator is 5x. Okay, I change signs again of everything. So this is negative 15, that's negative 0x squared, and this is positive 20x. I get that. When I bring down, I do my estimation again, get a 4. Get those. And I suppose I'll show. Make this one a negative, make that one a negative. Doesn't matter on that one. Make this one a positive. Okay, so I get 11x plus 11. So what is your answer? All of this plus that over that. Now, this skill is not an end to itself. This skill is a tool for a future skill. Okay? You're just putting a wrench in your toolbox that you'll need to unscrew a nut later. There's the formal answer. Well, here's another one. This one's going to be just about like the last one. What? Okay. It's this stuff up here plus that over that. Notice they didn't have to show the placeholder down here. Ready?
Yep.
Okay, we're going to skip over that one because it's just like the last one. Now we're going to do synthetic division. Okay. Synthetic can be a little quicker because you're not writing down as many characters. Now, this problem, if we were to do it by synthetic division, we would do it this way. Here we just write down the coefficients in decreasing powers. And again, if you're missing any powers, you got to put in those zeros. Now, what about this and that? Here's what about. Remember when we factored stuff, if I had like x minus 2 and x plus 5, then equals 0, then we would take x minus 2 equals 0, and we would take x plus 5 equals 0, and get positive 2, and get negative 5. Remember that?
Mhm.
When you're doing synthetic division is an additive process. Long division is a subtractive process. Remember that third step was always subtract. Okay. Well, in this one, we're going to add down each time. Because of that, in synthetic division, instead of using the factor, we're going to use, instead of using the factor, we're going to use the root or the solution. Okay? So we're going to use positive 2 instead of this negative 2 from the factor. And this is 1. Okay? Now, based on that, we can go on. Now, what's going to happen on here is you're going to bring down this first number. Always just bring it down. Now then, you're going to take this number times that, which in this case would be 6, positive 6. Now we're going to add these two and get negative 8. Okay. Now we're going to take this 2 times that. Okay, right here we added. Okay, we're going to take this 2 times this negative 8, and in this case, we're going to get negative 16. Okay. Once again, we're going to add down. And in this case, we would get negative 26. Okay. Now, actually, I should put that under here, like so. This is the remainder. It always will be. I'm telling you. Okay? Now, what is this thing? What do these numbers mean? Well, these numbers meant x squared, x, and just 10, right? These numbers mean 1 degree less, x, number, remainder. Okay?
So the last term you don't.
Last term is your remainder. So if they ask you what is the answer to this, then you would say the answer is 3x minus 8 minus 26 over x minus 2. Okay.
So could you go over again on how we got the 2 multiplied all the.
Repeat your question.
So with this 2 that you multiply all the terms with 3 and you get 14.
Yeah.
All right. Can you do it instead of doing how you got that?
Sure. How did I get this 2 instead of minus 2 is your question.
Yeah.
Okay, that is a factor. Okay, if that factor is equal to 0, and for us to graph it, it would have to be, then what would we get from this? We would get x minus 2 equals 0 plus 2 plus 2. So x equals 2 as a solution or a root. Those are interchangeable words. In synthetic notation, we use the root. when we divide synthetically. When we divide long division, we use the factor. When we do long division, it's a subtractive process. When we do synthetic division, it is an additive process. This and that are kind of the opposite parts of this thing. Okay, just like subtraction and addition are opposites. That's maybe the best way I can explain that. Did I answer your question adequately?
Yes.
You sure? Okay, well, 2 times 3 is 6. Add them, you get -8. 2 times -8 is -16. You add them, you get -26. Your quotient is 3x minus 8. In other words, this line will always be 1 degree lower than that because you have divided out 1 degree, one level of power. Okay, and then we have the remainder still on this one. And contrary to everything else they've done, they just showed it as remainder instead of in fractional form. Okay, what about this one? Well, first thing we got to do is put these in order. 4, 3, x squared's missing. Okay, and over here we're okay in that respect. So what they're doing here is this is just simply ordering that. Here's the 4th degree, here's the 3rd degree, here's the missing 2nd degree placeholder, here's the 1st degree, here's the 0 degree. Now that we've done that in order, we can take the coefficients. Coefficient of this is 1, coefficient of that is 4, 0, 5, and -6. Notice instead of +3, which is the factor, x plus 3, we use the root or the solution -3. Okay? So we bring down the first number. We take -3 times this 1 and we get -3. You want me to draw my arrows? Would that help any?
Yes.
Yes, okay. So I bring this down. Then I take this times that. Okay, which gives me the -3. Whoops. How about I aim my arrow correctly? This times that, which gives me that. Okay, now I'm going to add these, and I get 1. I'm going to take this times that 1, which gives me that number. I add these down. I take this times that, which gives me this one. I add these down, and then I take this times that, which gives me that thing. And finally, I add these down. Now, that's the process. What about the answer on this thing? Remember, this was really x fourth here. And this was really x cubed, and this was x squared, and x, and technically x to the 0, anything to the 0 power is 1. Okay, that's not a 6. So, because we have divided out a first degree, okay, because we've divided out an x to the first, that means that this answer is going to be 1 degree lower than it started. So my answer then, this will be x to the third. This one will be plus 1x to the second minus 3x to the first plus 14, just 14, technically if you wanted to, it's times 1, with a remainder of negative 48, which could be expressed as minus 48 over x plus 3. Okay? But from here to here, you will always drop 1 degree. Well, there it is. There's the summary on it. I guess I need to erase my scribbles. Schönheit, as my German ancestors would say. Okay, so here you see we've got 1 degree less than we started. Well, here's another one. Want to do this one or keep going? Yay, nay? Yay? Okay. But you never thought you'd cheer for a math problem. Okay. Suckered you in on that one, didn't I? Okay, so I've got 5 negative, whoops, those aren't in order. Highest power is y cubed. 2y cubed, and then plus 5y squared, and minus 4y minus 5. Okay? And what am I going to divide by? Negative 3. Okay? So, bring this down. Oh, you know what? I don't need these, do I? So bring down the 2. Arrows or no arrows? I'm not going to do arrows this time. You figure them out. Negative 3 times 2 is negative 6. Okay? 5 and negative 6 gives me negative 1. I add down. Negative 3 times negative 1 is positive 3. I add down. Negative 1. Again. Negative 3 times negative 1 is positive 3 again. I add down and I get negative 2. So my remainder is negative 2, filling in the powers. My highest used to be a 3. This used to be a y cubed. So I will have 2x squared minus 1x minus 1, remainder 2, negative 2. Okay. I don't know that it's any easier, but it's certainly a whole lot less writing.
So on a given problem, it doesn't specify using long or synthetic, is it just dealer's choice, or is there like a specific set of instances where synthetic is better?
Excellent question. Question was, if I don't give you an instruction to do one way or the other, does it matter which I use? And the answer to that is maybe. Just what you wanted to hear, right? For synthetic division to work, this has to be a 1y or a 1x to the first power for synthetic to work.
Okay.
Okay. If it's not a 1y or 1x, again, to the first power, then you'll need to use long division. That's why I say maybe. Good question, though. Because actually, I think on my test, I have maybe 2 that you've got to do long division, 2 you got to do synthetic, and 1 you can do however you want to. I haven't looked at the quiz for a while. I'm probably going to have to rewrite this one from last semester. Okay. Ooh.
This one I don't like.
3 pounds.
The thing's going to break down into this. And as you see, this goes into one of those perfectly, so I know I'm going to get a 0 remainder. That won't factor. We have to, it'll become an imaginary number eventually using the product property of square roots. But you see how 81, that's a conjugate. That's how I get this. Now let's do what it says to do. Okay, I got p to the 4th minus plus 0 p to the 3rd plus 0 p to the 2nd plus 0 p to the 1st minus 81. I'm starting to think I was going to have to go to the bathroom. Okay, so this gives me a 1, a 0, a 0, a 0, and a negative 81. What am I going to divide by? Positive 3. Okay. So I bring down the 1, multiply and get a 3. Add these 2 and I get a 3. Multiply and I get a 9. Add these 2 and I get a 9. Multiply and I get a 27. Add these 2 and I get a 27. Multiply those 2 and I get an 81. Add those 2, 0. Remember me telling you because that thing factored, I knew that it would go in perfectly. Okay. So what is the answer on this? This is p to the 3rd, p to the 2nd, p to the 1st, plus, let me put some numbers, some signs in here, plus no remainder. So here is your answer. Okay. I see a couple of blank stares. Anything bothering you on this one? Okay. Well, we're probably just about to see it again.
So are the signs between the zeros, where we send where we put the zeros, are they always positive or are they always plus signs?
Doesn't matter. Zero has no sign, neither positive nor negative. I used to always use positives. Seems less confusing to me. Okay, and there you see what I got, resulting in that thing. What have we successfully done? We've taken this factor right here out. Okay, we've taken this factor out. By the way, I skipped a step in here. This actually was p squared minus 9, p squared plus 9. Okay, that was, and then this piece further broke down into these two. I hope all of you realized that before, but I didn't actually show it. Okay, I knew this would work because I could see where that was going, simply because I've done it enough. Okay, maybe at some point you can get where you can recognize some of those things, but it'll take a while. Okay, it'll take a while. Now, if I took this times that, I would get this. These two multiplied together would give me this thing. And I would have factored out this one. So do you know what? I could take this thing and I could divide it by a p plus 3 factor, and it would go perfectly. How do I know that? Because it's a single factor. Okay. What? Shh. Yes. Actually, all this really is a long-winded way of factoring. Long division and synthetic both, all they are, I remember I told you they are just a tool to do something later. Well, that tool that they are is to take powers higher than 2, because if it's a power of 2, you can use the quadratic formula. But for taking powers of higher than 2 and ultimately factoring, that's what we're really building up to. Okay, and like I said, I'll teach you some things about how do you know what to try when you want to break down a higher power equation. Okay, so that's kind of where we're going long term. Let's see, I've lost my clicker. Any questions on this before we go on? Okay, there's another one. This one's very similar to that last one. By the way, that won't factor. Well, actually it will. That will factor. Rule D. Off of that sheet I gave you. This thing will factor into x plus 1 times x squared minus 1p or 1x plus 1. So we could, you know what? Look at that. Look at that. So if we do this synthetic division, that ought to be my answer. Let's see if that's correct. Okay, so I've got x cubed plus 0x squared plus 0x plus 1 which gives me 1, 0, 0, 1. Now, I'm going to divide it synthetically by -1. Okay? Bring down this 1, and I get -1. Multiply those, and I get +1. Whoops. Here's the -1. -1 times -1 is +1. Now I add these, and I get +1. Multiply those, and I get -1. Add those, and I get 0. What does this translate into? X squared minus x plus 1. Okay. And that'll always do that. Question before I go on? No? Okay. Complex fractions. Oh, doesn't that sound like fun? Okay, now. Here it tells you what it is. It's what this is saying has got a whole bunch of stuff. We're going to have to play the common denominator game. Is how we deal with that stuff. Now, add or subtract them in the numerator, form a single fraction, divide, blah, blah, blah. Here's a complex fraction.
So would that be the fraction of 5x over y divided by nx over y squared?
I don't know, I wasn't listening to you. It was too hard to listen to you then. I got confused and lost. You may be right. We'll see, okay? Now, if I work that problem, how do I work it? Yes, I flip it. You know what I like to call this kind of problem? Dolphin math. Why? Flipper. Okay, so we're gonna flip it. And change it to times. And then numerators times numerators. Denominators times denominators. And reduce it if you can. Okay, 2 goes into both of those, so 9 tenths. Okay. This problem could also be rewritten as 3/4 divided by 5/6. Okay. What would we do with this based on that? Well, obviously it's this fraction divided by that fraction, right? What did we do over here? We flipped and changed to multiplication. What do we do here? We flip and change to multiplication. And from there on, it's the same. So how do we work this? Well, 5x squared over y times y squared over 10x. And I'm going to have to get rid of some of my arithmetic over here. I'm not done. This y goes one time, y times over there. Y divided into y squared goes y times. This 5 and that 10, the 5 goes once, the 10 twice. This x divides out one of those two x's times each other. Have I got all the canceling done that I can do? Technically, that's called factoring, not canceling. Canceling is when you add opposites. Okay, so what do I got left? I got 1 times x times y, or in other words, xy, over 1 times 2 times 1, or just simply 2. Or I can write this as 1/2 x y, either of those two answers. Okay? Now, are complexes as scary as you thought at first? What do you do with them? You just take the denominator, meaning the bottom two, flip and multiply. What if there's only 1 on the bottom? What if there's only 3 numbers? There's a hidden 1 under the 1 below. Okay? Now let's see how they're shown. Looks pretty much like what I did so far, except I skipped that step. I went straight to this step. I'm lazy. Here. Excuse me, I like expending. I didn't know work any better than what it was.
Expenditure processing.
Yeah, something like that. Keep it simple. Yeah, there you go. That'll work. Okay, so we got this thing. We still got to simplify it. Oh, they did it the hard way. They actually use the exponent rule. When you divide same bases, you subtract the exponents. When you divide same bases, you I was doing that mentally. Okay. When I said this y to the first cancels out one of those, well, I was basically doing that mentally. Okay. So anyway, you get the same thing I got with a whole lot more work. I would never show that step unless it was unless some of these were negative powers to start with, then I might. I mean, I could have like a -2 up there in a problem. I could make up a problem like that. Then you might want to actually use those rules. Well, what about this one? You guys get started on this one and I'll work it while in the background. Questions on this one?
Yes.
Louder, please. Where?
No, that was 6a squared, BA squared, not 6a squared. It is indeed 6a squared.
That's 6a squared, yeah. I guess my sixes and b's look a little alike.
They do.
So do my twos and z's. That's why I put crosshatches on the z's.
Same here.
I like, oh, my keys, man.
Do you do that in your name?
Me?
Yeah.
I do now. My teacher in high school made me when I would write my name on worksheets. She gave me 0.
Okay, well, we won't go there.
That would be why.
Yeah.
Okay, so any questions about this? You're just too ancient.
Thanks.
I'm not that far.
You are in your
I'm
30s.
7 years old.
Okay,
Graduated in 2012.
now, everybody write down this problem. Can't do that there. Because that's the hot spot. There are the steps to working that problem. If you can read my scratches. Find the least common denominator of all 4 denominators. Okay? I'm talking about these 4 numbers right here. Second step, multiply that least common denominator, whatever it is, times all 4 numerators. Third step, cancel everywhere you can. And if you have done it right, this row of denominators will become 1s. This row of denominators will become 1s. And then you simply flip and multiply. And simplify. With that said, go home. Like E.T. said, go home. We're a little bit ahead right now. Okay, for my online class, I look forward to seeing all of you Saturday.
Thanks. Yeah, no problem.